Today we will train our first objects detection model, and we will use faster RCNN architecture. Let's do it. First of all, we need to change runtime to T4 GPU because the calculations are really time consuming and it is better to take T4 GPU. Okay, let's import our models. NumPy for calculating, Matplotlib for visualization, OS for special tasks, I will show you later. CV2 and Peel for computer vision, Torch for our models, and datasets for creating dataset. Okay, first of all, we need to download the zip file with our dataset. Here we can see it. Yes, cool. Then we need this function, because in this dataset we have pictures and masks of these pictures. But we need to train the detector. That's why we need to change masks into bounding boxes. And this function is doing it. So let's take a look at the masks that are in last 3 images of our dataset. And here we will see what we want to get in the end of the function that is defined here, bb from masks. Okay, nice. You can see that this picture, this mask, become picture with bounding box, and others do it too. So we need a class for using our dataset, as we have already done in the last seminar. Function init, getItem method, and len. Okay, here we will return our image and a dict with such keys as boxes, labels, masks, image ID, area, and isCrowd. So what's more, we can add transforms function for avoiding overfitting in the training process. So let's create the object of our dataset. So we need to run this cell firstly. Let's repeat. Okay, nice. So let's look at the first element of our dataset. So you can see a picture, and now you will see the descriptions to this picture. Here you can see that there are 2 bounding boxes and information about the area of each bounding box. And let's look at keys of our target. Boxes, labels, masks, image ID, area, isCrowd, as I have already said. Okay, and here you can see the bounding boxes. As I have already said, we will use faster RCNN model. As we have done in the previous seminars, we will take this model from Torch, here faster CNN predictor. And this function will return us a model depending on the number of classes we want to train. We can look at model's description here. It's really big, as we already know. So, backbone, here, our convolutional neural network. And then ROI heads, So here you can get acquainted with the layers of this model more in detail. What's more, we need code that will set up our training process. We will get already ready files for this from Coco. Okay, nice. This GitHub repository has been cloned. Here we can see the files we need. So, and in this version of Torch, here we need to delete torch.6 model because it's not valid this time. Here, you can see it. So I will delete and all will work. Okay, we want to get transform for avoiding overfitting, and we will apply random horizontal flip with argument 0.5. Okay, here we create dataset and dataset test, and then splitting the dataset into train and test sets, and apply data loader. For training process, we'll use dataset with batch size equal to 8. It will be shuffled, and the number of workers, number of cores will be equal to 4. And for dataset test, we need batch size that is equal to 1, shuffle equal to false, and also 4 workers. Okay, so we need to specify the device. In our case, it is CUDA. The number of classes is equal to 2, person and background. Then we define optimizer. It will be SGD with these parameters, and we define learning rate scheduler, which will change learning rate with the increasing of steps of training process. So let's do, for example, 3 epochs and start our training process. model. 1 second. Where we put here return model. And then let's look. We need to specialize the model. Let's do it. Model is the output of this function. Oh, I know. We didn't run this cell. Our model was not specialized by number of classes. That is equal to 2 in our case. And now it will work without this cell. Okay. We set up training process. Let's look at the training parameters. Learning rate is equal to this number. Loss is really big at the beginning of the training process. So, as I have already said in the last lecture, we have neural network that answer the question, that calculate the probability of belonging to a class, to a certain class. And here you can see loss of this neural network. And also we use bounding box regressor, which is the neural network 2. And here you can see loss for this neural network. I have already said that there is an RPN neural network, reason proposal network, that also is trained in this process. And here you can see the loss of this entity. Okay, first epoch is ready. Let's look at metrics. Here we use average precision metric with different IU thresholds. Okay, learning rate is increasing and loss is decreasing. All is good. Worth noting that loss is decreasing in all entities that are trained in this process. Loss classifier, loss box regressor, loss European box regressor, loss objectness. Okay, our training process is finished. Let's do an inference, look at our results. So we put the model into evaluation mode. Let's look at prediction. The prediction in the first picture of our dataset. You can see that our prediction consists of 3 bounding boxes. And here you can see scores. Model's confidence in these bounding boxes. So we need to change the format of our picture for using PLT tool. And here we can see the input of our faster CNN architecture, faster CNN model. And let's look how this model works, how it deals with this picture. So you can see 3 bounding boxes. Okay, and only one is correct, but it is already okay. We have trained only 3 epochs. Let's look, for example, at the 10th image of our dataset. Okay, prediction. Wow, a lot of objects, you see? Let's look at the picture. Yes, we can see a lot of persons here. That's why the number of bounding boxes is quite huge. So as you can see, the quality of our model is not really well, but it is detecting persons actually. Let's continue our training process. For example, let's do 10 epochs and then look at the inference. As we have continued our process, the loss is small at the first epoch. It's okay. Okay, now the average precision metric is really high. At IOU equal to 0.5, it is near 1. So it is only the third epoch. We need to wait for the 10. Okay, let's stop it after fourth epoch and look at the results. The number of bounding box is decreased. Let's look. Okay, nice. You can see that now, after training another 4 epochs, the results become better. Let's take a look at, for example, 100s. Oh, sorry. Let's look at 5th. How many predictions? Oh, a lot, quite a lot. What is the picture? Yes, a lot of people. Inference. Okay, you can see that there in the area of picture where persons are really far from the camera, there are a lot of errors. There are a lot of invalid bounding boxes that our model detects. And here too. But it detects person. Yes, with a error, but it is solution to the object's detection problem. So we need to just upgrade these methods, and in the future we will get really accurate models. Thank you for your attention. Goodbye.